Welcome back to Dad as a Programmer. Today we're going to take a quick look at the history of computer systems and give a really brief overview of how some of the parts of the computer work. The very first generation of computers would be called the era of vacuum tubes, and this happened after World War II until about 1959. And they were used to amplify and switch electronic signals. And remember that programs are run by electronic signals being turned on or off very quickly. So the first generation of computers were giant vacuum tube run machines. The next generation was the transistor era, and this was the era where you really started to see things emerge. For example, punch cards, uh, programming languages like Fortran and so forth kind of came out, and we really started to get into the art of computer science and having a better way to communicate with computers. So the second generation is the transistor era. The third generation of computers is the era of integrated circuits from 1965 to 1971. And these really revolutionized computers. It was also the first time that we started using silicon chips in computers. So if you've ever heard the term Silicon Valley, well, that's because that's where they were manufacturing those silicon chips. That is the third generation of computers. And finally, the fourth generation of computers is our microprocessors. And From 1971 moving forward, microprocessors continue to get better, although the rate of improvement has slowed down. And That is kind of the era that we are still in today, is the fourth generation of computers, or the microprocessor generation. So it's important to have an idea about what the IPOS model is. And the IPOS model stands for input, which would be like typing; process, which would be the computer receiving the key strokes; providing output, displaying it back to you, for example, on a monitor, what you typed in; and then storage, if you were to save the thing that you typed into the computer. So IPOS: input, process, output, storage. A computer system is made up of four parts. It's hardware, so for example, the motherboard, the processor, the CD player, the microphones attached to the computer. That would be the hardware of the computer. The software, that would be everything from, say, Windows or Mac operating system to PowerPoint here being displayed, your internet browser, all those programs running on the computer. That is your software. Networking, which is the ability for the computer system to talk to other computers and share data and resources. So when you're chatting with somebody on the internet, you're connecting to them over a network. And then finally, storage. That is how the computer stores data on a hard drive or a flash drive. So if you save a file, that is going into the computer's storage. Now, the word CPU, people even use the word CPU the same way as they use the word computer, but the CPU is describing just a small part of the computer, but maybe maybe the most important part. It's the brain of the computer, and it's responsible for running all the programming code, all the instructions, and performing calculations. Um, and a really good CPU is generally going to be a better experience to use on a computer. It's going to run smoother than if we had a really bad CPU. And a CPU stands for Central Processing Unit. Central Processing Unit. Now, there are different types of computers. There's desktop computers. That generally means there's a tower or a small box. There's a monitor that's not connected to the same thing as the box is. Um, and that's typically found in the home or at offices. Then you have laptops. That's where the monitor and oftentimes there's a built-in mouse, and everything is built into the computer. You can still connect peripheral devices, for example, like another monitor or a mouse, but oftentimes the laptop has everything on it you need. You have the monitor, you have a touchpad for a mouse, you have the keyboard built in. There are tablet computers. These are small devices that you would hold, you scroll with oftentimes through a touchscreen interface. And then finally, smartphones. Smartphones are basically just miniature computers. They oftentimes have the very similar features to what a tablet computer or a laptop, but they're smaller and they tend to not have as good of a CPU. So once again, it's kind of important to harken back here to, what's running on a computer. Like how does the computer work? Well, it's being run on either programming languages. Remember, we have those executable files or we have those interpreted languages that we run on the computer. And when we also have these other things called scripts. And scripts are oftentimes interpreted languages, and they do things for your computer. So if you've ever logged into a computer and seen a bunch of windows come up automatically and doing certain things, that's oftentimes something that somebody wrote a little script to turn on or off a bunch of things. However, if we double click and we go into Microsoft Word or we double click on Google Chrome, that's running a executable. So in the end of the day, we're giving something to the computer. That is our input, whether that's types or clicks or our image through a camera. We're getting something back from the computer. That's output. And then we can choose to store that information. Okay. So the heart of understanding computing is inputs, outputs, and storage. So when we say computer systems, we're not just referring to a desktop computer. It's more than that. We're talking about how the hardware and the software talk together, how they interact with other components, and how those components interact with each other. So, a camera, this built-in camera, is part of the computer system. And so we would, but if I just take any random camera and don't connect it to the computer, it doesn't become part of the system. But that camera is talking via what's called a driver to the CPU, and it's displaying that back on a monitor. And so we're describing how a part of that system works.